modify the color. You can change the color accordingly. So I'm going to choose this teal color right here. We can also select individual parts and change the surface material. And then say I choose the chest part, and then I say I want to change it to a different color. And you can see this has changed to this pink color now. Then changes to orange. And then this is sort of like the color that I want. And then let's go into more details. First is diffuse. And then there's lighting. Let me go into the rendering view here. Go back to surface. For the specular, if you change the exposure of the lighting, you can see that it changes on the model itself when you drag back and forth. For the size of the lighting changes. The closer you are, the brighter it is. And then when you go further down towards the right, it's more blurred out. And then the reflection, you can see when I drag the reflection bar, it becomes more and more metallic-like and reflects more of the environment around itself. There's also a transparency adjuster. And then you can see through it. And then there are other specifications below as well. So try it out and play around with it. So next, I want to show you different images that we could actually put onto the model. There are none right now, but say if I wanted a wood image texture, it changes the model to into a like this wood marbled texture. We can also go into image and then load an image that we created ourselves or that we have pre-saved ourselves. So you can please try it out. Next, the lighting. You can see on both the left and the right, there's two spheres. On the left side, there's some lights. Represents how light is moving from the front of the model. When you change the actual light source from the directions, you can see how it changes the lighting on the actual model. So if you change to the back, the second sphere, you can see the lighting is projecting from the back, so the front is completely black since there's no light being shattered onto it from the front. And then some other specifics, for example, the shadow. You can see the shadow changes and how much you want. And then the softness of the lighting. And then you can change the softness of the shadow itself as well. And there's are also many other options as well that you may try out. So one important feature is the sun. If you enable the sun, you can actually change the location in the world according to different cities that are already preset in the software itself. And what you can do is actually simulate the actual sunlight in that specific location, which are also all latitude and longitude accurate. Say a reason is not located in the preset menu, what you can do is also edit the latitude and longitude coordinates yourself, and then it will change the lighting and show you the lighting changes in that specific area. You can also change the date and time, so you can see exactly what your model would look like in that specific in that specific area, in that specific date and time. And if you press on time, it'll choose a specific time for the location that you put in to the coordinates in real time. It's reflecting that specific region's actual conditions. So please try it out on your site as well. So next, let's move on to the camera option. So here, there's a memory tab. We're going to pick the camera object. You can see in the browser up here that there's a camera that you have just chosen. And then go into the meta camera perspective, and then you can see where that camera is located. So right now we're still in the meta camera view. So say if we use the camera view that we just created, you can actually drag and change the perspective of your camera just by dragging and moving it in the actual windows here. So we can actually do rendering using this new camera perspective. To go into the rendering, GPU ray tracing, and then render. And then you can see it's really fast, and you can see it'll generate the model again. And then let's save this. Save the image. Let's pick JPEG, which is a common file type. So let's save it. So we can save this as a multi-layer as well. So now we can see, we can shape it as a Photoshop image. And then press save. So please try it out. So now we're going to make a simple animation using this model that we just created. So let's pick the part with the arms first. You can see the center position of the arm is right here. But if I want to do an animation, I want to change the center position from here to the top of the shoulder area instead. So let's change the center line. And then click on the center of the shoulder. And then make sure that the center line is around the shoulder. So now you can see it's rotating according to the type of movement that we selected. So let's make the motion now. Go into Tools, Part, and then go into the Rotator. And then go into Right View. And then click on the center of the shoulder. So you can see the rotator has been added into the browser. And then we're going to pick all of the parts and then bring it down into the category with the rotator as the main branch. So that it's easier when we're making the actual animation. So this is the rotator left arm rotator. Now let's make the animation. In View, go into Motion. Press Sequence. And then go into the rotator of the left arm. Make sure that it's the rotator of the left arm in your browser. So in the first keyframe, we're going to make sure that the needle is at 0. So we're going to make a 1 minute and 30-second video animation. So we're going to need about 239 keyframe needles for that. So the 1 minute 30 seconds or 239 frames need the needle ends up around here, and then set the ending frame here. And you can see half of the triangle is located at the top of the needle at the end, and this is where our animation will end. So now, let's change the animation so that the rotator actually rotates. So the keyframe increment at 119 in the left side, let's put in -90, which means -90 degrees, so that the movement is moving. In the arm, it's going front. And there's a blue line representing the motion. And you can see the arm is moving up. And then at 239 increments, we'll change the degree back to 0, so the arm goes back. And then put a marker here. And then let's play. And then you can see the robot is moving its arm up and then going back. Moving up and then resting. So please try it out on your side as well. All right, let's move on now. So now, we're going to show you how we're able to link Shade3D with UC Winroad by exporting this model and the animation into UC Winroad. So go into, first choose all of the parts and then go into export and then go into, we're going to export it using the FBX format today. And then we'll put in the parameters according to the guidebook, and then we'll export it. Choose everything in geometry, vertex with face, and then in material, uncheck the last box. And then press OK. And then save it. And then name it as robot or whatever you want to name it. So it says that the export has been finished. So let's take a look. So first, open up the UC Winroad software that was in the package that my colleagues probably has sent to you already. So this is a simulation of the Shibuya Square in Tokyo, Japan, saved under the citydesign.rd file. So please try opening it up on your computer as well. So now I'm going to import the robots into this environment here that we have saved up in UC Winroad as well. So this is a simulation environment that we'll be using. And then we're going to import it through the MD3FBX format. And then load the robot in the FBX format. And then let's open it up. So you can see the movements of the animation. And you can see that it's been successfully imported into UC Winroad. And then press OK. And then let's press Add Walker. In the path pace, press Robots. And then you can see the model has been added. And then let's close it. And then let's start the traffic and see how it looks. So now you can see the robot, which has been imported, is now moving on its path along with the arm movement through the animation that we generated. All right. And that concludes the parts for Shade3D and linkage with the UC Winroad. Now we're going to switch gears and learn a little bit more about UC Winroad and its applications. Please give us a minute to switch gears here. So right here, we have our UC1 software, which we use to create engineering applications purposes. Here, this is a bridge pyre and the specific measurements and dimensions. This is also available in a 4-window split view interface. So what we're going to do is, as I've mentioned in the very beginning, UC Winroad or Shade3D, they can do BIM, SIM, design check tools, which has been updated in all our latest versions of our software. So we can actually see how that works here. So right here, you can see in our software, the very specific details, rebars, and alignments are all simulated and displayed right here in 3D in this software environment. We're going to use IFC and export this in standing for Industrial Foundation Classes, which has been becoming a standard in the BIM sim world. So let me import it into UC Winroad. First, we can actually do the BIM sim checks in Shade3D before we import it into UC Winroad. So you can check the IFC information and all the details right here. Once you have inputted into Shade3D as a model, And Shade3D is really great for working with different types of models, since it needs no further plugins, and you can import and export all types of models with just a few simple clicks. It's really, really useful and efficient, and an efficient software to work with. So here you can see all the structures inside the IFC Pyre. All the rebar specifications are listed and can be analyzed. So now let's export this out. Into UC WinRoad through the FBX formats. Don't change anything. Save this in our desktop or our drive as an XBX file. So it's just taking a few seconds to load here. And then now let's go into UC WinRoad, and here is a pathway, overhead pathway. And we're gonna move our pier in underneath this overhead pathway, overpass. So it acts as a supporting bridge pier structure. And then you can see the specifications here, and now has been imported in. You can see all the rebar details. And this is a specific model. And we can rotate around it and choose a specific model in UC WinRoad. You can see all the coordinate and GPS details for that specific bridge pier, which are all real life accurate. Okay. So now I'd like to show you something else. This is a terrain from UC WinRoad. What we can do is actually download this entire area. And this area is generated from an OpenStreetMap source. So you can see right now we're located in Tokyo, Japan, in this area here, in the Shinagawa area here, where our head office is located. So let me just download this area here. And we'll use this area to work, which is an open source. This is from OpenStreetMap, which is an open source data map system. So we have imported the models and buildings in this specific area. These are all GPS coordinate real life accurate. And then from here, you can see from the satellite view, what we can do is create roads with just a few clicks, which is what our software UC WinRoad really excels at, hence the name UC WinRoad. And then just with a few clicks, you can see a road has been generated. And then you can see this terrain and the elevation specifications are all listed on this window here, and you can just modify it as you need for your project. And once I apply it, you can see this road has been generated. So what we can also do is edit this section. So there are default roads, but what we can do is edit this road. And let me just make another road here. So if I move the road above to the white part here, it actually represents a bridge that has been created. And the higher up it is, the higher the bridge is. So this is the green area down here, represents where the terrain is. And if you're going under this elevation, you're making a tunnel. If you're above in the white area, you're making a bridge. And today we're going to try making a bridge. And then we'll try to import our bridge file from the IFC file later on as well. So now we're making an overpass bridge way. And what we can also do is also generate traffic and put some cars onto this road, which is pretty lonely right now. So you can see generating traffic is super easy as well. You can see there's different vehicle types from motorcycles to sedans to race cars. And if I click on a car, I can also take a ride in the passenger seat. You can see different views from the left to the right. There's different FOV options. So this is like really as if you were in a real car simulation as well. What we can also do after we come out of the car, you can see that the overpass driveway, it needs to be supported by something, can't really just fly in midair. So let's load some models from our FC file and FBX format files as well. So this is going to be imported into the software using FBX format this time. So give it a few seconds to load. And then let's check the structure and make sure that we can see every detail of every rebar structure. Where we can deselect or select whichever feature you want. And then press OK. And let's put it in. So you can see the model has been selected according to the real world GPS coordinates that we're seeing here in the window. And then you can see you can move this pyre up or down. And that's it. Let's go back. As I've mentioned before, This is the Shibuya Square in Tokyo, Japan. It's the busiest intersection in terms of foot traffic in all of Japan. Let me just mute the sound. And since the traffic started, you can see the trucks and the cars on the road. Pedestrians are walking and moving. You can see the light and time of day is changing, and the shadows are moving, sunlight is moving, since this is all real world accurate. If we go into the nighttime, we can also see the advanced lighting, allows you to see the lighting from the street lights and the headlights from the vehicles, which are all up to automobile industry standards as well. So let me go into a vehicle and go for a ride. You can see we can change the weather conditions, what it's like to drive in a rainy season, what it's like to drive on a snowy day, what the ground conditions, how the conditions change according to the weather. And then you can also see right here, like at a construction field, we can do some analysis for noise, for wind, and we can also load in things that we might want to build for construction and simulate how construction process might work in the specific conditions. We can do noise simulations to see how the noise would be generated from this construction project and how it would affect the surrounding environment as well. How the residents would be affected when the construction would be going on. Okay, now let me just change to another site. So right here, all these were saved previously in UC Winroad's database. This is a road construction with an excavator working on excavating the soil here to build pipelines and other construction, road expansion, etc. So you can see Rosie Wind Road is not only good for traffic simulation, it can also do a lot of operation simulation and large machinery training and simulation, like this one here. So you can get a view from the inside as well as the outside of the machine. And this is a riverside area. Say if it's snowy, if it's sunny, how your environment would change, how people living in this environment would be affected. So you can change the colors. To represent the quality of the waters. Okay, let me just go back again. And here, that concludes our simple introduction to UC Wind Road as well. Sorry, please give me a minute to transition. We will be ending our seminar today, and we are, if any of our attendees